So here we're told that the tickets to a play are sold for $10 for balcony and $35 for lower level seating. If the average value of the ticket is $27.50, how many of each are sold? And the total number of tickets sold is 100, so how many of each were sold? Okay, so for part one, we can't really tell exactly how many tickets are sold. We can only give the answer as a proportion. So for part A, we're going to say that, well, we have our $10 tickets, we have our $35 tickets, and the average value was $27.50. Okay, so we have $7.50 between here and here, and we have $17.50 between there and there. And we can just determine our proportion based on these numbers. So I can say that, maybe 75 $10 tickets, and we can say that there were 175 $35 tickets, but it will be in that ratio. And again, because of the proportional nature of this, I'm just going to crisscross those proportions. So this one kind of ended up there, and this one ended up there. Okay, so it could have been 20, 75, 25, or 75 $10 tickets. I'm just going to make a little chart here. So $10 tickets and $35 tickets. Okay, it could have been 75 and 175, or it could have been any proportion. It could have been 3 and 5, and that would also give us an average of $27.50. Okay, so any proportion like that. So we could even do 20 divide by 5, so we can get, what would that be? That will be 15, and 35 would also give us the right number of tickets. Okay, now if we want to solve this explicitly, then we need part B to this problem. Okay, the part B tells us that there's 100 tickets sold. So if that's the case, then now we can guess and test. We could probably guess that it's going to be 30 and 70, but we could also come up with a system of equations for this. So my system is going to look like this. Okay, so I can say that x plus y equals 100. If that's the case, x represents the number of $10 tickets, and y is going to be equal to, let me just rewrite that there. So y is equal to the number of $35 tickets. Okay, and to get the value of this, we can just say that, the $10 tickets times x plus the $35 tickets times y is equal to the average value times all the tickets, which is x plus y. And then we have a system of equations. So equation 1, equation 2, and then I'm just going to substitute to solve here. I can graph this. In this case, I'm just going to solve this by algebra, by substitution. So I'm going to take equation 1, and then I'm going to put it into equation 2, where I have 10x plus 35 times y. And instead of y, I'm going to use this expression. Okay, so that's what's going to go into here, 100 minus x, and that's going to be equal to, and I'm going to expand this out, 2750x plus 2750y. And again, I have to substitute for that y. So that y, eraser here, I'm going to substitute for that y with 100 minus x. 100 minus x. Okay, so then expanding this all out, I get 10x plus 3500 minus 35x is equal to 27, so it's going to be 2750 minus or plus 2,750 minus x, oops, that's going to be minus 2750x, okay, so those x's will cancel out on this side, and we end up with, by subtracting 2750 from both sides, I'm going to end up with 750 on the left-hand side. I'm going to end up with 10x minus 35 is negative 25, so I'm going to add 25 to both sides. And then x works out to be 30 tickets. Y works out to be, when I plug it back into equation 1, I get 70 tickets, and that's what I was looking for. So for this answer, for part B, I'm just going to highlight this in yellow then, for part B, the answer in part B was 30 tickets for X and 70 tickets for Y, or 30 $10 tickets and 70 $35 tickets.